Alright. This is Trigonometric Integrals. So the whole thing with these is we certainly like to be able to look at these powers here. And the reason why is we have this specific form that we like, which I will put over here. So this is our form of the sine to the m power cosine to the n power dx, and probably one of the easiest ones, if we can do, well, I don't know if it's the easiest one, but one that we like a lot, is if we can turn these both into even powers, then I can kind of separate them a little bit and do that whole sine squared plus cosine squared equals 1. So that's what I'm going to kind of do. Alright, so the first thing I'm going to do is I'm going to take this sine, and that's to the 7th power, and I could rewrite that as sine to the 6th power of x times sine of x, because that's still the same thing, right? And then cosine squared x dx. And what that allows me to do is I can now say, well, because of my rules of exponents, I could write that as sine squared x to the 3rd power, and then I still have sine x cosine squared x dx. And again, the reason we really like to do that is because remembering that I have my sine squared x plus cosine squared x equals 1. So I can substitute and write this as sine squared x equals 1 minus cosine squared x. So that's what I'm going to do for that piece right there. So that's going to end up becoming 1 minus cosine squared x, and that's still to the 3rd power. I still have my sine of x, and then I still have my cosine squared of x. Alright, now we start doing all this substitution stuff where, I didn't mean to write that, where I'm going to substitute and say, well, let u, write this kind of off to the side over here, equal the cosine of x, because I want to get this whole u du for my integral. And so then this derivative, my du over dx, my derivative with respect to x, of course the cosine would be minus sine of x, and then solving this, I could solve it minus du equals sine x dx, and I can use that to substitute there. And then of course my cosine squared, I can substitute my u, and my cosine squared, I can substitute my u. Alright, so away we go. So this is going to equal, I'm going to go ahead and throw this negative out front, just don't forget about it, the integral of 1 minus, my cosine is u, but I still have to square it, and I still have to make this to the 3rd power. This cosine squared is u squared, and then of course my sine x dx becomes that negative out front du. Now this makes something a whole lot easier to solve. There's just one kind of horrible step, is that remembering here, this is where you cube a binomial, and so hopefully you kind of sort of remember this. It's probably been a while, meaning let's just kind of talk it out. And so this equals, I still have my minus sign there. You cube the first term, and so let's just go ahead and write it like that, 1 cubed. Then you take 3 times the a, which is my 1, and square it, times my b term, which is u squared, plus 3 times my a term, leave it alone, times my b term and square it, and then minus my last term cubed. And then, of course, get my parentheses going on here, I still have this u squared du. So all of this is just simply your definition of cubing out that binomial. Alright, so now we just simply have minus my integral, make this look a little bit better, 3u squared plus 3u to the 4th minus u to the 6th u squared du. And then I can distribute out this u squared to everything in the parentheses. Missed one there. So that's minus u squared minus 3u to the 4th plus 3u to the 6th minus u to the 8th du. And now I'm home free. It's just time to integrate. So meaning minus, this becomes u cubed over 3. I integrated u squared. Minus, bring that 3 out front, u to the 5th over 5. Plus, bring that 3 out to the front, u to the 7th over 7. Minus u to the 9th over 9. And then, of course, I can distribute this negative, but also remember a reminder that we said way up above, remember that u equals cosine of x. So let's just do it in one step where I distribute the negative and I plug in, everywhere I see a u, I plug in a cosine. So I'm going to get minus cosine cubed x